Record.
Good evening, everyone. So welcome to our third session. Today we're going to be talking about cluster analysis, and we will also go over a simple example of networks. So cluster analysis, we're going to again use the IRIS data set for. So if we put it, again, 50 observations, 5 variables, and contains data about the essentially properties of flowers. So let me copy IRIS into a separate data set that we let's call it features. All right. The reason I've done that is because for the purposes of cluster analysis, we need to get rid of the speed column. So in that column, now that look at it. Okay, so this column is gone, and we only have the features: length, width, of sepal and petal. IRIS is already we didn't know that IRIS doesn't have any missing values. In the with the other data sets, at this point you will also need to make sure that we don't have any missing values. Have missing values in k-means clustering algorithm. You need to make sure of is that all variables are standardized. So variables of your features are in a different. You need to standardize them between each other. The algorithm is fairly simple. It takes 2 parameters. It's a k-means algorithm. It takes the data as the first argument, and then the number of clusters. In this case, it's going to be species. But typically, you would want to experiment with how many clusters do you want to be in your output. In case it's going to be 3. To all right, variable result, and these are the means for each cluster for each feature. Clustering vector shows the cluster in which corresponding value is located. So the first observation is located in cluster 3, 76 is located in cluster 2, 150 is in cluster 1, etc. And we have available components, and essentially when you generate a k-means cluster, you have variables are there to help you. The cluster centers between, and you can call them using the $sign. Say if you call the cluster, it will show you what cluster each observation is in, the one that we just observed over here, but if you need to call it out separately. The result centers, for example, will show you the matrix of for each cluster, which we also had when we just called for the variable. Size will basically show you the sizes, number of points within each cluster. Also remember that King's clustering is dependent upon initialization. So the means, the observation assigned to the clusters, they might vary from time to time. And that goes back to setting a seed. The need is the possible desired reproducible results. So when you need your results to be reproducible by somebody else, or you want them to be in format in some way, that's where you need to set the seed. Because the observations, the clusters are going to change on upon initialization. So let's see how this clustering did. So let's create a table. Where would the column set and the cluster column of the of the results variable. So in this table we can see that Setosa, all 50 observations are in cluster 2. In cluster 3. Versicolor, we have two observations in cluster 1 and cluster 2. Virginica, we have even bigger split between clusters 1 and 2. So if we plot it out, if we want to look at it visually, we will we'll use the function. And we're going to just visualize two features, petal length and petal width. And color it by the cluster column. Okay, so we do have 3 distinct clusters. Some of them have mapping, but overall we have 3 groupings, right here, here, and here. And the same thing with the sepal. And we also have some distinct clusters, some overlapping between 1 and 2, but overall we see 3 distinct groupings. This is an example of k-means cluster. Now, I wanted to get back to data quality for k-means, which I mentioned earlier, because you can't have any missing values when you're conducting k-means. So what do you do if you encounter a data set that has NA missing values? Let's create a random table with missing values. So for, let's load sales, and let's create a matrix. And choice. Next. Assign it to 3 columns and 4 have, in other words, we're going to be assigning quarters to the rows and have fixtures A, B, and C. And the letters, the numbers represent the sales per each quarter. But what's going to happen if there were no sales, or a salesperson just forgot to enter the for that month? We'll have a missing value. So the with names to the columns of the mix, which are the products. And the rows we will so Q1, Q2, okay, so we see missing values in two products in second and fourth quarter. The easy trick to replace those values would be using a loop. We're going to use the for loop and run it. So we're going to use the number of columns. So we're going to essentially be saying for run through the number that equals number of columns in the sales variable. And iteration, we're gonna essentially test is NA function test if the value is missing, and if it does, then it returns true. If it doesn't, it returns false. And we're gonna columns actually. Okay, and those missing values. So once we identify the missing values, how do we populate it? Well, there are techniques for that, but each one is to essentially to populate it with the mean of all values for that variable in that column. So that's what we're going to do. We're going to use function. So it's going to set each value of the column. The number of iterations is going to be as many as there are columns in this variable. Each one, the sales for each one, the for loop will test value in each column for missing value. If it is a missing value, it will assign it the average, the mean for the values in that column. Yeah, the values in that variable. Oh. Yeah, one part it automatically sets the punctuations for you. So if you open a parenthesis, it automatically opens another one. If you opening one parenthesis, it it creates the closing one, and sometimes it creates issues. So we have to here.
That's me, my bad.
You left any errors?
It's I in. Okay. Okay, looks correct.
That was correct.
Yeah.
That's closing one. That is correct.
I see I see, after true.
Mm-hmm. Oh, yeah, that's
see
right.
the wrong.
Yeah. Sorry.
Oh. So comma I means what?
Oh, no, I think I skipped something there.
So the all information about Bobby.
Because I see twice. I see another comma.
What's this for?
Okay.
So now, if we call for the sales matrix, it replaces the missing values in the second quarter with averages for that variable. For one, it was 51, and for PAS 41. So in this, NA.rm, essentially it's a logical value indicating whether entries should be stripped before the computation proceeds. So it's just to put there. And have any questions at this point? Okay. Okay. So that was an example of k-means clustering. The next thing we're going to look at is going to be the neural nets. I'm going to demonstrate a very simple example. Artificial neural nets, ANN, basically comes in the package called neural nets, so you need to install it first. So once we install it, if we need to require when to call our function. Essentially, it's load grid mass libraries. So so we're going to use the data set that contains data on infertility, and it's called infer. And so essentially, that's if you look at the variables for that, it has 248 observations. Variables are essentially education, age, parity, use. In fact, we can just call it in the help section. And so the data contains information on potential patients, female patients, and it has information about their educational level, their age, already number of prior induced abortions, status, and it's essentially 1 or 0 case control. Prior spontaneous abortions, and then match set number and stratum number. So we want to predict base inputs and outputs whether we have an infertile or fertile case. We're going to call the neural function and assign it to the n variable. Okay. Here, so you see in the tip that popped up, it essentially telling you the structure. The neural net function is very flexible. It allows for a lot of algorithms. The ones that we're going to use are going to be the formula, which will include the and start typing it up. So it's going to plus C use and then the next argument is going to be data and be inferred. Equals to ERRFCT is essentially that controls the way basically it's a function that calculates an calculation of an error. You can also use different ones. There's also, you can, instead of CE, you can type in entropy, and or instead of cross entropy, you can type in the sum of square errors. I'm going to use CE. I'm not quite positive exactly how those work. Sometimes one, and there are numbers of papers discussing the advantages of each. I'm just going to use CE for the purposes of this exercise. And output. With the linear output, we're going to set it because this is a categoric variable, and the output is not numeric. So we're going to set it to false. And let's run it. It's time for neural net to get processed. So now we have a list of 13 variable n. So we have this is essentially a result, the output. So we're converged to the optimal solution, which is 4,627 steps. It has about 130 cross-entropy errors. Now let's plot it and look at how it looks unvisualized. Okay, so we have 3 input variables, H parity, spontaneous, and we have 1 output, case. These are essentially those are intercepts, a constant. So anytime you're dealing with inputs, one of your input is going to have to be a constant. If you don't have any inputs, your outcome will be to average. There's then go along the connects are essentially weights. So, so it's a very simple example of how neural net works. And got any questions at this point? Okay. Well, great. So again, to go over, we went over the k-means clustering and neural networks examples. Next, Yelena, when is the next work session?
It's next Friday, but I'll have to look at the topics we're doing. Guys, the next assignment, right? Can you guys tell me what your next assignment is on? I need to check. Because we've got the text mining, but it's not until the after, right?
Right, and that was my understanding too. So in any case, we're gonna it's gonna be an announcement. We're gonna announce the topic for the next WebEx and exact time. If anybody have any questions in the meantime, please email me or Lena and put it in the discussion area. Okay, there are no more questions. Then that concludes our session for today. Thanks for coming, and we'll see you next week. Yelena, are you there?
Yes, I need to stop the recording.